Welcome back, y'all. Here for part 2 of 5.8. So we got through about half of this last time. I think we left off the door problem. Yes, the door problem. Okay, so we went over how to simplify radicals and how to multiply radicals and simplify them from there. Now, in this video lesson, we are going to go over dividing square roots and radicals. Okay, so an important concept here is that when you have a fraction inside of a radical, remember that's not simplified. But what you can do is you can rewrite it so that you can take the square root of the top over the square root of the bottom. So you just split the square root up into two different ones. Okay, so for example, square root of 36 over 49, you just square at the top, which is 36, square root of 36, square root of 49. Well, conveniently, those are both perfect squares, so square root of 36 is 6, square root of 49 is 7, so that comes out to be 6/7. Okay, and if you think about this, 6/7 multiplied by 6/7 gives us 36/49, which is this guy right here. So, naturally, when you square root it, you just square at the top and square at the bottom. Okay, so let's go over some examples. Okay, so looking at this, problem A is previous example we just did. So if we square at the top, we get square root of 64, square at the bottom, square root of 49. Well, again, these are perfect squares. So square root of 64 is 8, square root of 49 is 7, so that's just 8/7, and we'll leave it like that. But on B, it's not quite as simple because 8 and 50 are not perfect squares. So what you can do with that first is you can simplify. So I would simplify the inside first. So 8/50ths, this is the same, those are both even, so we can divide those by 2. It's the same as 2 times 4, and then 2 times 25. Then you have your x to the third on top, x on bottom. So these two just cancel. So really this is the same as square root of 4 over 25. And then remember, you can simplify these by subtracting the exponents. So that's 3 minus 1, so we're left with x squared on top. Okay, and then from there we can square the top and bottom, because now, if you notice, 4 and 25 are both perfect squares. Hooray. So we square the top, 4x squared, over square root of the bottom, which is 25. Well, square root of 4 is 2. And then this one is x squared, so that's one pair of x's, so we have one x on the outside. And then square root of 25 is 5. And we don't have any radicals left, so that is simplified. Ta-da! Okay. Alright, let me give you a problem to try. Okay, so go ahead and try some of these. I will do them also, and then we will come back and talk about them. Okay, pause this in 3, 2, 1, pause. Alright, welcome back. So, part A here, we just do square root of 144, which is 12, square root of 9, which is 3, 12 over 3, and that actually simplifies further to 4. 12 divided by 3 is 4. On B, I simplified the a's first, so I changed that to a squared on the bottom, and then I squared at the top. Square root of 36 is 6, square root of 4 is 2, and then I had a squared left on the bottom, so that just became a. On C, we have a radical left because when you square root 25 y to the third, well, square root of 25 is 5, so that's where this 5 comes from. But then this y, that's 3 y's. So we only group it in pairs, so that pair comes out, and then this one's left over, so it's got to stay by its lonesome on the inside of the square root, isolated from the other y's. Okay, and then square root of z squared on the bottom is just z, because there's one pair of 2's, or one pair of z's. Okay, so we're left with this guy. Alright, next. Wow, this is going to be a super quick video. Okay, so this one, we also need to talk about how to rationalize the denominator. This is an important part of talking about radicals. So remember, when you have a radical in the bottom of in the denominator of a fraction, it is not simplified. So it says we need to rationalize the denominator. Now it says rationalize because if you look at square root of 7 here, that's an irrational number, because when you square root 7, you get this long decimal that never repeats and it never ends. So that is an irrational number. So when it says rationalize the denominator, what that means is change it from an irrational number into a rational number. Okay, and I'm going to show you how to do that. So naturally what you would want to do is just square the top and square the bottom. Problem with that is that gives us 3/7 here. This is not the same as square root of 3 over square root of 7, because really we could combine those square roots and get the square root of 3/7. The square root of 3/7 is obviously not the same as 3 over 7. Okay, so you can't just square the top and square the bottom. That is a no-no. Bad. Okay, so what we have to do, essentially we want to square the bottom, but we can't do that by doing the square operation. So if I want square root of 7 squared, that's essentially the same as saying square root of 7 multiplied by square root of 7. So instead of actually squaring the bottom, what I can do, I can multiply it by square root of 7 and get the same result. Okay, because that's the same thing. But if I multiply the bottom by square root of 7, I also have to do that to the top. Okay, I'm not multiplying the top by square root of 3, I'm multiplying it by square root of 7. Okay, so these have to be the same. Alright, and now what happens is we just multiply straight across. So square root of 3 times square root of 7, that gives us square root of 21 on top. Square root of 7 times square root of 7, well, that gives me square root of 7 times 7, which I have a pair of 7s, so those come on the outside. So I just get square root of 21 over 7. And now I have rationalized the denominator, because I went from square root of 7, which was irrational, to a regular 7, which is rational. So now this is simplified because I don't have any roots in the bottom. The only radicals are in the top. Okay, let's look at B now. So on B, we can rationalize the denominator first, or what we can do is we can simplify the square root of 8. Okay, so let me rewrite this. If we're just focusing on the bottom right now, the square root of 8n, I can break that down further into 4 and 2. I didn't do this with the 7 because 7's prime, but 8 you can break down a little bit. So notice we have a pair of 2's here, so we can rewrite this as this 2 comes on the outside. Whoops. And then this guy's left over. So 2 square root of 2, we only have one n, so it's got to stay on the inside. Okay, so this is going to be our new denominator. We just simplify it. We still have square root of 7 on top. And then we can rationalize the denominator from here. So let me erase this over here so I have some room. Okay, so let me rewrite over here. Let's ignore this guy right now. Alright, so let's rewrite this, square root of 7 over our new denominator, 2 square root of 2n. And now, again, to rationalize the denominator, you just multiply by the radical on the bottom. So I don't multiply by the whole number 2 here, I'm just multiplying by the square root of 2n on top and bottom. Square root of 2n. Bang, bang. Okay. Now because you're multiplying a radical with a radical, we can just multiply the insides. So we get square root of 14n over, we still have our whole number 2. When we multiply these guys, well, that just eliminates the radical. So we get times, because you have a pair of 2n's basically. So we get times 2n down here. And then simplify that. So we get square root of 14n over 2 times 2 is 4n. And our denominator is now rationalized. And our radical is simplified. So the only root is in the top, which is what we want. Okay, last one, I am going to let you try these, and then I will do them, and then we'll talk about it. Ready, pause this in 3, 2, 1, pause. Alright, so first one, I just multiplied by square root of 3 on the top and bottom, and I get square root of 6 over 3. Remember, you can't cancel the 6 and 3 because one's in a radical and one is not. On C, I split it into 2 square roots first, so square root of 7s over square root of 3, and then multiplied by square root of 3 over square root of 3 to get rid of the radical on the bottom. So I get square root of 21s over 3. Remember, these guys, these don't cancel, they just cancel the radical. So you still have 3 on the bottom. Okay, the denominator doesn't go away, it's just 3. Then b was kind of a long one because I simplified the bottom first. Broke 18 down into 9 and 2, which is 3 and 3. So I took the 3 out. 2m is on the inside still. So then I multiplied by the top and bottom by 2m here. And then I get 10m in the radical on top over 3 times 2m, which is 6m. And again, the m's won't cancel because one's in the radical and one is not in the radical. So these m's do not cancel. And that is our final answer there, folks. So, let me know, well, don't let me know anything. Please go and take your quiz. That will be 5.8 part 2. And yeah, I guess let me know if you need any help or have any questions or concerns. And I will gladly address those when I can. Alright, that's all for today. This is an 11-minute video. Hopefully you watched it. Sorry there was no guest appearances today. But stay tuned. There's more coming in the future. Adios, amigos. I will catch y'all on the flip side.